Hi guys, so my name is Morgan Ingram. My personal presentation is on anthrax and bioterrorism. So this is going to be a brief overview of what is bioterrorism. So a biological attack is a deliberate release of pathogens or other bacterial agents that are intended to make you sick. Now this may not always be obvious. It will take multiple people presenting with symptoms and actually going to the hospital or their physician with these symptoms, and a pattern needs to be established. And there's also a great difficulty between distinguishing between bioterrorism and just an epidemic. So biological agents can be dispersed by spraying them into the air, person-to-person contact, infecting animals that carry the disease to humans, and by contaminating food and water. So many of these agents are found in nature, but they can be modified by terrorists to make them more dangerous. For example, they can have increased antibiotic resistance, increased resistance to the host immune system, or just enhanced symptoms that can lead to death or mortality. So, while a biological agent may injure or kill people, animals, or plants, the goal for terrorists is to further their social and political goals by making their civilian targets feel as if their government cannot protect them. Excuse me, I have a cold. So, the main biological agent I will be talking about is anthrax. So, if a biological bioterrorist attack were to happen, Bacillus anthracis, the bacteria that causes anthrax, will be one of the biological agents most likely used. So, why is this? Anthrax spores are easily found in nature. They can be produced in the lab. They can last for a long time in the environment. So these microscopic spores of anthrax can be put into powders, sprays, food, and water. Because they are so small, you might not be able to see them, smell them, or taste them when you contract this disease. Excuse me. So, as I said, it can be created easily in the lab. It's also incredibly durable. Spores of anthrax can lie dormant for years before entering the living host, where they reactivate and multiply. This makes anthrax an incredibly dangerous bioterrorism weapon. So, anthrax has been used as a weapon before, which I'll talk about some other incidents in a moment. And anthrax is classified as a Tier 1 toxin. So what does that mean? So a subset of select agents and toxins have been designated as Tier 1 because these biological agents and toxins present the greatest risk of deliberate misuse with significant potential for mass casualties or devastating effect to the economy, critical infrastructure, or public confidence. They pose a severe threat to public health and safety. Anthrax is identified as one of these Tier 1 toxins, and as a result, it can kill quickly if it is not treated. This over here is just a picture of some of the Bacillus anthracis. Oh, excuse me. So, as I mentioned before, anthrax has been used in the past, unfortunately, for biological attacks. Anthrax has been used in bioterrorism for over a century. We saw it in World War I, where Scandinavia deployed it against the Imperial Russian Army. The British Army used it in World War II against German livestock to weaken their food sources. In 1993, a religious cult in Japan deployed anthrax against civilians in Tokyo. During the first Gulf War, Iraq reportedly produced 8,500 liters of anthrax, and as a result, a total of 150,000 U.S. troops were vaccinated with anthrax toxoid. Maybe the most famous attack from anthrax was in 2001. After the 9/11 attack, letters containing anthrax spores were mailed to news media offices and 2 U.S. senators. This unfortunately resulted in 5 deaths and the infection of 17 others. This was traced back to the U.S. Army Medical Research Institute. Over here is a picture of one of the letters that the anthrax pathogen was sent in. It's quite chilling message. Okay. So here's an overview of anthrax etiology. So, Anthrax is naturally occurring and lives in the soil and can infect wild or domestic animals such as cows, goats, and sheep. Humans, in turn, contract this anthrax by handling infected products, mainly animal products. The bacterial responsible for anthrax, B. anthracis, produces a capsule that is small, slightly curved, and a diameter of 1 to 1.5 micrometers, and a length of 3 to 10 micrometers. So bacilli grow optimally in enhanced carbon dioxide and are non-motile. Their preferential growth on phenylethyl alcohol blood agars with characteristic gelatin hydrolysis and salicine fermentation. These can be visualized using methylene blue or ink India stain. Oops, India ink stain, my bad. So here is just a picture of the anthrax cycle. As you can see, the cows and other livestock are the carriers of the disease. Biting flies can get infected from them and in turn infect humans through cutaneous measures. Humans can also ingest the infected meat and get a GI exposure. And they can also inhale anthrax spores in the air. Cows can also, in turn, release feces that are contaminated with anthrax, which can affect the vegetation around the area. So this is just a brief overview of anthrax epidemiology. So the fifth plague described in the Old Testament book of Genesis may be among the earliest descriptions of anthrax. Natural occurrences of infection are rare. Anthrax infection is, however, an occupational hazard for veterans and farmers. During the last 30 years, the indigenous U.S. incidence of any anthrax infection has been less than 1 case per year. That is, until 2001, when the Center for Disease Control and Prevention investigated several threats in the United States. So that was the male bioterrorist attack that I told you about. So in October 2001, this attack had 22 confirmed or suspected cases of anthrax infection. So as you can see, since there have not been any cases of naturally occurring inhalational anthrax infection since 1976, even a single occurrence could raise an alarm for a bioterrorist attack. So I'm going to go into the anthrax pathology now. So B. anthracis is a gram-positive bacteria. Its capsule is a poly-D-glutamic acid that protects it from leukocytes, phagocytosis, and lysis. These are the common immune responses in the human immune system. And it is very resistant to these. So anthrax toxins are composed of 3 entities: a protective antigen, a lethal factor, and an edema. So I'll go into those a little bit more here. So the anthrax toxins have 3 entities. The protective antigen is a protein that binds to cell receptors within the target tissue. Once it is bound to these cell receptors, a fragment is cleaved free to expose an additional binding site. The binding of the edema factor at this site results in the formation of the edema toxin. The binding of the lethal factor results in the formation of the lethal toxin. So, edema toxin acts by converting adenosine triphosphate, or ATP, to cyclic adenosine monophosphate, CAMP, and this acts through a second messenger system. Cellular CAMP levels are in turn released and increased, leading to cellular edema within the target tissue. So, according to the CDC, the lethal factor is not well understood, but the CDC speculates that it may inhibit neutrophil phagocytosis, lyse macrophages, and in turn cause a release of tumor necrosis factor interleukin-1. So death from anthrax occurs as a result of the effects of the lethal toxin, which causes animals to bleed out from all body orifices. So as far as the incidence of anthrax goes, most of these cases are in fact cutaneous, with 95% according to the CDC. The remaining cases are inhalational at 5%, gastrointestinal at less than 1%. This is a picture of some B. anthracis inside host cells, all these purple little circular things. Those are actually the bacteria infecting the cells. So now I'm just going to go into the different kinds of anthrax infection and exposure. So the most common form is actually cutaneous. And this is contracted when spores enter the body through a cut or scrape on the skin. This can also include through animal and insect bites. This form develops within 2 to 5 days. It results in the lesions that are edematous and necrotic. And these get worse over the time. So in the case of neck lesions, as the one shown in the picture, edema and lymphadenopathy may impinge on the airway. This can cause stridor and respiratory compromise. So an interesting fact is that anthrax was described in early literature of the Greeks, Romans, Egyptians, and Hindus. The term anthraxis means cold in Greek. The disease is named after the black appearance of its cutaneous form. If you look here, this man has a big lesion on his neck due to anthraxis, and it is in fact black and necrotic, and that is how anthrax got its name, because it causes these black, cold lesions on the skin. Sorry. Excuse me, I have a cold. So, moving on, the next form is gastrointestinal anthrax. This results when a person consumes an anthrax-infected animal. This is like cows, goats, sheep, any kind of animal or animal product that someone consumes that's infected by anthrax can cause gastrointestinal anthrax. This is actually the rarest form in the U.S. with less than 1% incidence rate, but it can be deadly, so it's important to look at this. Between 20 to 60% of this gastrointestinal anthrax results in death, according to the CDC. And it will present as abdominal pain, fever, nausea, vomiting, malaise, anorexia, and diarrhea. This can cause soft tissue edema and lymph node enlargement in the GI system. And as a result, there can be distributive and hypovolemic shock due to the enlarged blood vessels, which allows for the edema to pass through. Ulcers and necrosis on the GI tract lead to hemorrhage. This is what ultimately will lead to death if not treated. So this picture here shows a bunch of blood in the lumen of the GI tract, and this is a GI hemorrhage due to anthrax. Moving on to inhalational anthrax. This is at risk. People at risk for this are those who process wool and animal hide. Inhalational anthrax is actually the most dangerous form. It puts people at risk for respiratory failure and respiratory collapse. And unfortunately, it does have a 92% mortality rate. Inhalational anthrax begins 1 to 3 days after exposure, so it's pretty quick, pretty abrupt. People contract this disease. And the common symptoms are fever, non-productive cough, fatigue, and chest pain. What is really interesting about this is that patients will actually improve for a few days. They will get drastically better, and they will believe that they are well and that they just had a flu or some kind of bug. So, unfortunately, a few days after that, they will have a rapid deterioration. And this is seen as a high-grade fever, respiratory failure, hematemesis, acute coronary syndrome, decreased level of consciousness, coma, and, unfortunately, death. This is what makes anthrax an extremely dangerous biological weapon. People will present with flu symptoms. They just believe they have a flu or a seasonal cold. They'll get better, believe they're healed, don't need to go to the doctor. Then they'll rapidly deteriorate, and they can become comatose and even die. Another interesting form of anthrax is anthrax meningitis. Now, this is actually pretty rare because in the event that this occurs, the person may not be surviving. So, this is when the bacteriorema and hematogenesis genus actually spread to the central nervous system, which leads to central nervous system hemorrhage and edemas. As you can see, this is a 100% mortality rate, unfortunately. Meningitis is very deadly. And the fact that it can come from anthrax makes anthrax an extremely likely biological weapon that can be aerosolized and released. Over here is a picture of some central nervous system edema. That and hemorrhage, that is what causes this meningitis and in turn death. So, diagnosis of anthrax. As I mentioned before, if not treated, the mortality rate of inhalational and even gastrointestinal anthrax is very high. So it is absolutely imperative for an early diagnosis in order for survival. So how is this done? So B. anthracis can be seen in gram staining or blood cultures. Now, when this is in the laboratory setting, it's imperative that laboratory personnel take level 2 precautions and wear the correct proper personal protective gear because they do not want to contract this really dangerous pathogen. As you can see in this picture over here, this person is actually looking at a blood culture of the anthrax, and they can determine whether or not it's positive or negative. So, as far as the cutaneous cases, there can actually be punch biopsies at the edge of the lesion, the anthrax lesion, and they are examined by silver staining and immunohistochemical testing to determine whether or not anthrax is the cause of the infection. For inhalational anthrax, chest x-rays and chest CTs show widening of the mediastinum and pleural effusions and hemorrhage. I showed you a picture of a chest x-ray on a previous slide when I was talking about inhalational anthrax. And then for the meningitis cases, there can be lumbar punctures that show grossly hemorrhagic cerebral spinal fluid. So treatment. Most people are treated with antibiotics such as penicillin, doxycycline, and ciprofloxacin. Antibiotics have a high success rate in eradicating the bacteria of anthrax. So in the case when anthrax spores get into the body and are activated, this is when they start multiplying and infecting other cells. We can actually use antitoxins, and an antitoxin can be used to target anthrax toxins in the body. The CDC is currently working on more research for this antitoxin treatment because in the case of a biological attack in bioterrorism, a mass anthrax incident may exceed antitoxin availability and create a need for judicious antitoxin use. So what can be done about this? It's important that we have a disaster preparedness plan in the event of a bioterrorist attack where anthrax is used, or actually any kind of pathogen is used, but in anthrax in particular, we need to have a disaster plan. So what are the recommendations? So the CDC recommends that public officials in high-risk areas such as DC, New York, LA, all the big cities really, they should consider to have a stockpile of anthrax antibiotics to make it easier to distribute to people in need. So usually the anthrax antibiotics are stockpiled in the Strategic National Stockpile, which is managed by the CDC, and they are distributed for attack. But as you can guess, this is kind of far away from most places, and some people don't have transportation to get to this place. So it would be better if there were some local level CDC antibiotics that can treat the anthrax infection should a biological attack occur. So, kind of going along with this, a report by the Institute of Medicine said that if bioterrorists released aerosolized Bacillus anthracis over a large city, hundreds of thousands of people would need rapid access to antibiotics. So it'd be better to have local stockpiles. The U.S. Emergency Medical Services System agrees, suggesting that healthcare professionals should keep stockpile of them at home to treat their neighbors and people that don't have access to transportation. These antibiotics are effective when taken within 4 days after the exposure, so preparedness is of utmost importance in order to treat these people and help prevent them from dying due to an anthrax infection. Okay? So these are my references, and thank you.